I'm going to talk about is how we've taken a legacy abstracted in the ANI abstracting and indexing database, which the IT has been producing for 50 years, and turning that into an analytics platform using various tools and technologies in order to be able to rejuvenate the market. So some of you may have heard of Inspec. It's been around for a long time. It's been around since 1969. The precursor goes back to 1898. It's an ANI database which we sell traditionally into academia, into universities. It's discipline specific. It covers physics, engineering, computing. It's got about 18 million articles in there at the moment. 10 million of those are about physics, 5.5 million about computing control engineering. We add just under 1 million records a year. And they go through a process of curation, selection, and indexing to make sure it's a high quality database. It's intended that our students, our researchers, our customers in academia can more easily discover scientific content. We sell to over 1,000 universities and corporates and government departments worldwide. However, since 2008, since the market crash, the market started to decline. Firstly, because no one had any money left. Secondly, because user behavior was changing. Technologies were coming on the market, such as Google, which changed the user behavior so they don't expect to have to go to the library anymore to search for articles because they can just open their smartphone and find stuff online. They would search for what we call good enough. Not great quality data online. There's a large amount, as you know, of poor quality data online, but it was good enough for their purposes. So usage was declining, revenue was slowly declining year on year. So a couple of years ago, we instigated a project to see what we could do to be able to take the existing database, take the existing infrastructure, take the existing processes we had, and be able to build new products, new solutions to be able to reinvigorate that market. So for 50 years, we have been using this process where we bring in content from the top. There you can see we bring in articles from publishers, 750 publishers, 4,500 journals, 3,000 other sources of content. We bring these in, we curate them, we select them, we just take the good quality articles, the ones that are relevant to what our customers are doing. We bring the bibliographic information in, we stick that in the database. We also then take all these articles, take all the abstracts, and we index them. We have a team of subject matter experts, 250 or so subject matter experts, and they index these articles. They annotate each one with the relevant keywords, the relevant subject classifications. If they've got astronomical objects in them, they add AOIs. If they've got relevance to a particular type of patent, they add IPC codes. If they have numeric data, they add numeric indexing. If they have chemical structures, they add chemical indexing. And of course, all this is a hugely rich data set, which allows them to use very powerful, very advanced search interfaces to be able to find exactly the right articles that they want. However, they just like using Google. They like typing in quick and easy keywords to be able to find the articles which are relevant to them and just trusting in Google or Bing's rankings. So we've added this value to the content for 50 years now. It is very clear from talking to our customers, we've done a lot of market research, a lot of talking to our customers over the last few years, that the quality of the indexing is unique, that the fact that we have 6 different definitions of the word mercury, we have 52 different classifications for statistics, and that's just within physics, engineering, computing. So if you're searching for an article on a particular type of statistics, it'll find you just the few hundred or so which are relevant to that particular type. It won't bring you back 10 million hits, all of which can refer to multiple different types of statistics. The quality is a USP. It does allow people to find articles more quickly. The fact that we have a thesaurus of 10,000 keywords, a classification index of 3,600 different classification codes in a 5-level hierarchy means that people can find very, very specific articles. And what we've done is we've taken that highly structured, high-quality data set, and we've gone through the process of turning our thesaurus into an ontology using a domain model, putting it together with the data, building a knowledge graph, as other people have said about this, and building a UI on it, building a user interface and taking that out to customers and getting constant feedback from that in this analytics platform called Inspec Analytics. So what this allows people to do, based upon our discussions with customers about the specific needs they had, was they can drill down into the work that's been done, not looking at the articles, but looking at the trends, looking at what their own individual organizations have done. They can see not just how many articles a particular university has published or a particular corporation has published on electrical engineering, but within electrical engineering, power systems, within power systems, generating plants, within that thermal power stations and plants, within that gas turbine power stations and plants. And they can see which corporations around the world, which universities around the world, which universities within a particular country are increasing or decreasing their research on gas turbine power stations and plants. They can see the trends over time for an individual institution. They can see the trends over time globally. They can see who are the most prolific organizations, who to partner with, who to publish with, which journals to read, which conferences to attend to get up to speed on that one particular topic, which is information that's in the database, but it takes days or weeks or months to actually find that information by searching for all the articles. Finding the top funding bodies, finding the most prolific author, the most cited authors. All of this turns the database into a new value proposition. It's not about finding the articles on a particular topic. It's about answering questions about your organization. How has your organization changed? Who do you partner with? Which areas are you investing in? Which areas should you be investing in? And this allows us to do specific things for our customers. So for example, some of our customers are in Egypt, and what they want to do is they want to take a look at all of the 101 institutions, research institutions, government departments, corporates within Egypt, and they want to see what the top subject areas are, where they compete with other countries. So for example, for Alexandria University here, you can see some of their top areas, for example, thermoelasticity, they're 52nd in the world. Sorry, they're second in the world in thermoelasticity. They didn't know that. They like finding that out. But this is a database they trust, which gives them information which allows them to define strategic objectives. It allows them to see what the trends are. Are they still going to be number second next year? Who else is publishing on this particular area? Who's increasing or decreasing the work in that? Which funding bodies are available for advancing in new areas? You can compare multiple organizations and see, well, okay, so they're better than us they're better than us in electrical engineering, but within electrical engineering, we're actually superior to them in that particular area, and we're actually decreasing in this area, and we're increasing in that area. And they can make, again, strategic decisions. So it's all about being able to see who in the world is publishing on this, who within your peer group is publishing on this particular topic, and then being able to define KPIs. So this allows us to go from targeting students, targeting librarians who buy this database, to actually talking to the decision makers at our university customers and corporate customers, because then they can decide to expand the department, or they can decide to shut off a particular research area because it's not going to be profitable for them, it's not going to give them impact, and instead focus on the areas where they're stronger. Also see what the new topics, what the new buzzwords are that are coming along in the market to allow them to define the future. So one of the key points of this is we've done a lot of market research. We've done surveys of our customers. We've gone out and spent a large amount of time talking to a large number of our customers with our vendor partners as well. In-depth interviews, we've gone through a process of about a year and a half of building proofs of concepts, mock-ups, quite drastically changing the direction of where we were going, and in order to be able to actually end up with a minimal viable product. So this was delivered earlier on this year. We continue to deliver in a 2-week sprint in a standard agile fashion. And this has allowed us to move from the traditional librarians, as I said, so they're introducing us to the heads of physics, the heads of engineering. Because when those guys see it, when those guys see the interface that we've built, they start poking around and they start saying that we have to have this. And we say, well, you already have it, because you already have Inspec. So this has allowed us actually to stop the decline in revenue, which has been going on for 10 years, and Inspec is a significant revenue generator for the IET. But this project, building this new interface, has allowed us to reverse that decline, to actually start increasing revenue. Just within the last 6 months, just with a beta, by taking the existing database, the existing high-quality data, building a knowledge graph around it, talking to our customers to understand what their KPIs are, what problems they need to solve, what business problems they need to solve, and making damn sure that the head of physics will prevent the librarian from canceling Inspec because students are using Google instead. So, just to summarize, the market has changed. Behavior of millennials and Generation Zers, who are now in higher education, which is terrifying. The market has changed. The behavior of users using our product has changed and it has declined. However, using semantic technologies, building knowledge graphs, and linking this high quality, highly structured data allows us to recycle the product into a new value proposition, taking it to a new type of customers who have more money, which is nice. But the only way we've been able to do this is by engaging with customers to understand. There was a question from a talk earlier on about how do you ensure uptake of the product. You have to solve a business problem that your customers have. You have to be able to understand what structured data you have, how to add unstructured data if you have it, and how you can use that to solve a specific problem, and then focus on that, and then expand the offering over time. So it's not all about the shiny front end. Our front end is quite nice. It's point-click, drill down by clicking on a bar chart and things like that. There are other products out there which are very shiny and very lovely, and you look at them and then you spend 5 or 10 minutes digging, and suddenly you're finding that the underlying data isn't great quality. So we've been in that very lucky position where we have great quality data. Building somewhat shiny and improving the shininess of the front end is actually a pleasure. Working on your domain model is key. We've gone through a process with ConTech, with data language, with molecular connections, who are in the room, to be able to build a domain model, to be able to bring the structure together and turn it into a knowledge graph. But if you have poor data quality, you end up with a poor end product. And that is me.
Thank you, Tim. Do we have any questions? There's a question over there. Do we have a mic?
Sorry, where was it?
It's just over there. As far away as possible.
Keeps me fit, that's okay.
Thanks. Okay. Hi, Misha Rennie. I'm an intellectual property lawyer for the last 30 years, so it's very nice to see traditional data sources such as Inspec actually taking a very rich source of data, which is what everyone's been speaking about today, is what all these AI products actually need, because they're creating the tools, but if they don't have the data that actually gives them the basis upon which to create a business, then it's not going to run, because they need to. You've done your homework, you've done your research with your end users over the years. You know now what they want, and you've got the richness of the database which you've created over the years. And I think that's the way the AI industry has to go. It's got to look for the rich data sources. What is it you're trying to do? Get the widest spread of data, the rich data, and then create the products now to model them into these particular markets, which I think is, I applaud you.
Thanks.
As I say, I work for Dun & Bradstreet, so I know it from the data point of view from financial data, and repackaging data from all the stock exchanges in the world into packages and services that people actually want to use. So well done.